So welcome to your first lab for Sen 1120. In today's lab, I'm just going to go through some of the exercises and give you a heads up on what it is that we're doing today. Okay, so for this task, what we need to do is get the file test.cpp from Blackboard, and then we're going to save it into a folder called lab1, which is going to be within this home folder. So just to show you here, I've got test.cpp from Blackboard. It's a simple little program, and I've saved it over here in my Cygwin home, not my student number, but my user profile and lab1 folder. And there it is there. So all I need to do is fire up Cygwin. I need to just go to that folder, and then I'll just check, yep, there it is, there's my thingy, or my file. So I want to compile it. I'm going to use a very simple compile command. This is going to make a mycode.exe file. Okay, it's given me no feedback, so that suggests it has work. I can test that in two ways. I can just type in ls, and you can see that is my executable there. The other way is I can just use the Windows Explorer, and you can see it here as well. So if I want to run that, and there it is, it's printing out the word hello. This one waits for a cin to close. So that's all you need to do for task 1. So for this next task, what I've done is I've gone onto Blackboard and grabbed a few more files. I've grabbed the add.cpp file, and I've grabbed the make file. So all I need to do is look at a few different ways I can compile my code. Now the first way is the way we did it just then, using the g++ command, and this actually goes through and compiles the code. When it does this, this is your executable, and this is the source code. There is another way we can do it. We can do it using the make command. So the first one we can do is make, and I can literally just type in the name of a program which I want to make. So this has to correlate to a CPP file in the folder. And when I do that, you can see it just goes ahead and makes that. And now if I list it, you can see I've got an add.executable. It just makes the associated executable. So now if I wanted to run that, it would be pretty easy. So my first integer is 5, my next one is 7. So yeah, everything's working there. The other way we can compile programs is by having what we call a makefile. A makefile is a little script. It just says what compiler you're using, what you're going to be compiling, and what the output executable is. You shouldn't need to pay attention to anything else in this. Actually, the only thing you should ever need to pay attention to is the sources and the executable. So here we've got a simple makefile. It just sits inside the folder where you want to compile, and to run that you just type in the command make. And that will just go ahead and make the file. You can see it also makes any .o files as well, and you can clean those up easily. You can just go make clean if you want to remove any .o files. That's how to compile in 3 different ways. If you have any questions, ask your lab demonstrator about that. So I've now had a go at the Celsius to Fahrenheit conversion. This is basically the one that was presented in lectures. You can see you've got your inputs and your outputs, all fairly normal stuff. And then we're going to do some assertions. The assertions will cause the program to terminate and fail should anything not evaluate to true in any of these. So I'll just give that a run and show you how it works. So the first thing is we'll compile it, and that's compiled fine. So now we'll run it. So just to show you how the assertions work, if I put an illegal amount in there, let's say it's an interval of 60, you can see that the program has failed because of this assertion here. The low was too low. So let's try running that again with some decent values. So we'll start with 100 and we'll go to 200 in intervals of 10. So we should get 10 results here. Just looping around, giving us the associated Fahrenheit. The program can continue if you like, it's just all in a loop. But yeah, that's basically today's lab. So good luck with it all.